Continuing. So for Eddycon C is quite different. The calibration is quite different from Nortex 600 or Mentor AM. So this steps is just specific to Eddycon C and C. So the first step, you set the test mode, where you come to setting and you set if you are doing either expert tests or conductivity. We talked about that in our last video, so we'll stick with the expert. So the expert mode is applicable for welds and surface inspection. So the next stage, you will set the frequency. In this case, like I said earlier in our last video, we have a range of 0.1 to 1 megahertz. So you can play between 1 to 500, and we've decided to set it at 400. For the gains, we talked about 5 gains in this equipment. For now, we will leave them. We will not touch the gain. Then for the drive voltage, we will set drive voltage in the middle. The highest is 6. We'll leave it at 4. Then for filter, we will turn off filter. We'll turn off filter. We don't want filter for now. Then for the display, select probe. Then we are going to pick the right kind of probe. For the probe we are using now is the bridge probe. So we'll select the bridge probe. The bridge probe is already selected. Then we'll set the display parameters, the axis, the display, the grid resistance. For the axis, we already put it where we want it to be. The position of the 0 point, we already put it. And the grid, we already set the grid to this one. So if you want to calibrate, just a little information. First, you need to be sure you have chosen the right probe for the job. This is not a video for talking about the types of probe, but you need to be sure you are using the right probe. Don't go and use wet probe for surface inspection, and don't use surface probe for bolt hole. And choose the right probe, and also ensure that the probe is for the right material. Then the next thing you need to have is to have the right calibration standard, which is key, because if we are working with stainless steel and we use carbon steel to calibrate for stainless steel, it's going to give us an issue. For example, we know that carbon steel is magnetic and stainless steel is not magnetic, so it's going to affect the impedance value, because one is ferromagnetic, one is not. So you need to take note of that. So choose the right calibration block, the right calibration standard. Then also ensure that the equipment you are using is the right equipment for the right purpose. Having said that, let's dive into it. So this video is specifically for Eddycon C and CL. The steps for setting up and calibration for Nortex 600 is radically different from this in a whole lot of ways. So do not use this to go and calibrate a Nortex 600 or a Mentor EM. We'll do separate videos for that in due time. So this is just a breakdown of the steps to just make the whole process faster, so that we can get through it. The first thing is you set the test mode. I told you then to set test mode, go to setting and you pick expert. For all application, we are using expert. The next thing you are going to do is to set the frequency. We have done that in our previous video, so we'll set the frequency to 200. The next thing is to select the right probe. We've done that in the last video. You select the right probe. The next thing is to adjust your display. This is an example of where Eddycon C is radically different from Nortex 600 or Mentor. So it's quite different, though the principle is still the same. And if you understand the concept, you can find a way around. So here we are setting the axis. We've already done that. The axis is at the center. The display, we want our grid. The only thing I want to just change here, I need my light mode back. So I go to setting and change from standard to lights. So I go back. This is brighter. I can see my grid easily. My grids are clearer. That is why I went back to the light mode. The next thing, we set our drive voltage and extra gain. I also talked about this in our last video. Set it in the middle. So our drive voltage, I set it at 4 volts. Our extra gain from our setting, I set it at where are we? Our extra gain, I set it at 6 dB, which is the middle. So that is good enough for us. So the next part of the setup is to now find our lift-off curve. Before I will proceed with this, I will just briefly talk about a lift-off, though it's meant to be a topic of its own with a whole lot of explanation. But when we see the probe, this is our Eddy current probe. Okay, before I draw this is our plate. So our Eddy current probe, as it is, the coil is here, and it's already producing it already has magnetism that is induced as a result of, so you have the cable inside, right? So magnetism is already induced on this. When it gets to this plate, that is when it produces the eddy current. But when you start bringing the probe down, when you start bringing the probe down towards the plate, it gets to a point, not necessarily in contact with the plate, where the effect of this magnetism is already being felt on the plate. So the magnetic effect is already producing the eddy current. Not to the highest capacity, but you can feel that effect. So that distance between the plate and the probe, where you can feel the effect of the magnetism, is basically what we call lift-off. So this gap is very critical for all eddy current measurement, especially when you start performing other forms of eddy current like PEC. Lift-off is very critical. Or when you are doing coating measurement, or when you are doing your normal eddy current, lift-off is very key. So this lift-off, what happens is this guy has magnetism, the probe, and is coming to the plate to produce eddy current, and the eddy current is producing opposing magnetism, which will affect the voltage of this coil, thereby leading to an increase in impedance. By virtue of bringing this probe to this plate, impedance has increased, and that increase in impedance, if this is your lift-off plate, is going to show as a curve. This curve is what we call the lift-off curve. Now, why do we need this lift-off curve? It's basically telling the lift-off curve is basically telling us where the effect of the eddy current is felt on the unit. If we're able to get it and align it in a particular direction, we'll be able to say, oh, this unit is working, and we can constantly see our lift-off. So in determining the lift-off, we will put the probe in a plane area, and we'll take it up and down to determine, let's say, balance first. Always do that when you put the probe on the equipment. So we take up and down. What we are getting, we are not getting any clear signal. So what do? We are not getting any clear signal. We go to the preamplification. Let's reduce it a little and see how it will affect. Okay, so now we have a signal. So balance. If we want the signal to be bigger, we increase the general gain and see what happens. So let's know. General gain is still low. Let's go to extra gain here, and it's already at 6 dB, so let's not increase it further. So we increase our preamplification again and see, we balance and see how it comes out. Okay, so we have a much more clearer lift-off signal now. So this is our lift-off signal. This is our lift-off signal. Balance. So the next thing we do is to rotate the lift-off curve to the horizontal position. If we look at the position of the lift-off now, it's not. So there are several ways of doing it. You can keep pressing on this angle button. If you press on the angle button, it's changed from about 50 something to 108 degree. If I press again, it changes to 107. So it want to automatically set your lift-off curve to the horizontal position. That is what this button does. So this button automatically tries to set the angle of your lift-off curve to the horizontal position. You see, it's trying to set it to the horizontal position. So whatever lift-off curve you are getting, so with this, you see, it will keep adjusting whatever lift-off you get until it gets to the horizontal position. Now it is in the horizontal position. Alternatively, if you don't want to follow that route, you can just get to the angle. You can get to the angle, which is your phase angle, and start adjusting. If you increase, you see the direction we are going. That is not the direction we want to go. We want to get it to the horizontal direction on this side. Why do we need to do that? Because this, if you start taking your angle, this is 0 degree, this is 90, this is 180, 270, 360. So it's usually better for horizontal left. We balance again and see how it comes out. If it is horizontal, it's horizontal. But if we now look at the gain, we go to the vertical gain and increase the vertical gain and see what happens. We balance. So what we just try to do is to adjust the vertical and horizontal and overall gain as required. Take note, this is not the final setup of gain. The final setup of gain will be done when you are setting your sensitivity. So the next thing we'll try to do is to set our alarm gates to 80% of full screen light. Take note, we're always using the circular gate. So if you look at this machine, it's already set up to 80%, but we can adjust as we want. We can go to alarm and we can do fine adjustments on the step. We'll come down and we can step it by say 100 and reduce this until it is exactly almost 80%. So if you look at it, this is 20, 40, 60, 80. So this is exactly at 80%. So that is what we have done.